In this video, we're going to be looking at the current and voltage in parallel circuits. So I'm going to build this circuit. Instead of using a battery, I'm going to use a power pack. And then we're going to measure the current at these 5 positions in the circuit. 1, 2, 3, 4, and 5. To measure the current, I'm going to be using an ammeter. And an ammeter needs to be inserted into the circuit to measure the current. So I'm going to break the circuit and then connect it in at position 1. And as you can see, the current at position 1 is 0.56 amps. Now we're going to measure the remaining values at each position, 2, 3, 4, and 5. So position 2 is here, next to the first bulb on the first branch. So it's right here. So we need to break the circuit here. And we need to insert the ammeter into the circuit. And as you can see, it is 0.2 amps. Don't worry about the negative sign, it just shows the direction of the current. So if I swap these the other way around, you'll see that the negative becomes a positive. So 0.2 amps at position 2. Now we're going to measure the current at position 3, which is here next to the second bulb in the second branch. So I'm going to break the circuit here and insert the ammeter. And as you can see, the current is 0.19 amps. So now we're going to measure the current at position 4, which is here next to the third bulb on the third branch. So I'm going to break the circuit here and insert the ammeter. As you can see, the current is we'll take 0.18. Finally, we're going to measure the current at position 5, which is here between the power supply and the branch that has the first bulb on it. So we're going to break the circuit here and insert the ammeter. As you can see, the current is 0.58 amps. So what do these results show us? These results show us that the current, the rate of flow of charge next to the power supply, is shared between the 3 branches, between the 3 bulbs. Okay, so this 0.56 amps here is split and shared between these 3 branches. So that's why these 3, if you add them together, should be close to 0.56. And then at this point, when it flows around the circuit, okay, it becomes 0.58, which should be the same as this number, but is very, very close. So in a parallel circuit, the current is shared between the branches. Next, we're going to look at the voltage in a parallel circuit. So this diagram, circuit diagram, shows this circuit here. And we're going to record the voltages at position 1, 2, 3, and 4 over the power supply, and then each bulb in each separate branch. We're going to start at position 1 and we're going to measure the voltage over the power supply. To do this, we're going to be using a voltmeter and we're going to insert it over the power supply and record the voltage. And as you can see, the voltage over the power supply is 9.05 volts. Next, we're going to measure the voltage at position 2 over this bulb here, this first one in the first branch. So we need a voltmeter. Our voltmeter, you need to use it in parallel over the component. As you can see, the voltage is 9.02. Don't worry about the negative sign. If I swap these around, it'll become a positive just because of the direction of the current. So 9.02 at position 2. Next, we're going to measure the voltage at position 3 over the second bulb in the second branch. So we need to connect the voltmeter in parallel once again. And as you can see, the voltage is 8.86. Lastly, we're going to measure the voltage at position 4 over the last bulb in the last branch. As you can see, the voltage is 8.76 volts. So what do our results show? Now, these, in a perfect world, would all be the same number. But this shows that they're close enough. It shows that the voltage in a parallel circuit is the same. So the voltage is the same over each component. Now it's important to note that the bulbs in this experiment are all the same. These are identical bulbs, so the voltage over them will be the same. So the current in a parallel circuit is shared and the voltage is the same.